Hello everyone, my name is Khyati and today we are going to learn about chemical bonding. It is a part of ICSE Standard 10 syllabus and you are watching via Learn Yourself. First of all, chemical bonding. What is chemical bonding? The electrostatic force which acts between two or more atoms to hold them together and make a stable molecule. Electrostatic force. What is the meaning of electrostatic force? That the acting force between two atoms, a combining force between two atoms is known as electrostatic force. You can say it is a kind of force of attraction which holds two molecules together, which acts between two or more atoms to hold them together and make a stable molecule. This is important. Each and every bonding happens because the atoms want to become stable. If the atoms are stable, just like noble gases, then they will not go for chemical bonding by themselves. If the atoms are unstable, they want to become stable, so they will go for chemical bonding. This is the basic requirement of atom, so that they will become stable via chemical bonding. Now we will see some of the example that why noble gas is stable. These three are the noble gases: helium, neon and argon. Their atomic numbers, their proton count is 2, 10 and 18. First we'll see helium. Its atomic number is 2 and electronic configuration is 2. That means it has 2 also in its valence shell. Its valence electron is 2. To check how to write electronic configuration and what is the meaning of valence shell, and to understand this concept, check my video based on how to write electronic configuration. Then for helium, electronic configuration is 2. We'll go for neon. Its atomic number is 10 and electronic configuration is 2 and 8. Here the valence electron is 8. What is the meaning of valence electron? The outermost shell electrons are known as valence electrons. Then argon. The atomic number is 18 and here also the electronic configuration is 2, 8 and 8. It also has 8 electrons in its valence shell. Whoever atom has 2 in its valence shell, it is following the duplet rule. Whoever atom has 8 electrons in its valence shell, they are following octet rule. So neon and argon are following octet rule, whereas the helium is following duplet rule. That means they are stable in their valence shells. They are having a complete duplet and complete octet in their valence shell. So that's why this is the reason they are stable and they do not want go for chemical bonding. And other than these atoms, there are noble gases after this also. Helium, neon, argon, krypton, radon, xenon, they all are noble because they have stable electronic configuration. Now reason for chemical bonding is to attain a nearest noble gas electronic configuration. Here it is important. To attain nearest noble gas electronic configuration, each and every atom will try to attain its nearest noble gas element. To check this, how it is possible, see my video based on electronic configuration. There you will have an idea that how sodium will attain a nearest noble gas configuration just like neon and not like helium and argon. So what is the reason for chemical bonding? To attain a stable electronic configuration just like a nearest noble gas element. Now there are two methods for chemical bonding, that atoms will go via two methods to form a chemical bond. One is electron transfer, other is electron sharing. So electron transfer means the complete transfer of electron will take place between two atoms. So it is known as electrovalent bonding. And electron sharing means the electron will be shared between 2 or 3 atoms and they will form an atom. It is known as covalent bonding. Now there are some periodic properties affecting bonding. So to check this periodic property in details, ionization potential, electron affinity, electron negativity, check my video based on periodic table chapter. So ionization potential. What is ionization potential? The energy required to take out an electron from its valence shell. So as it is lower, it will be greater possibility to form a cation. As the energy will be low, the more possibility to form a cation. Electron affinity. What is the electron affinity? Tendency to acquiring electron. Tendency to attract an electron. As it is a higher, there are more possibility to form an anion. So electronegativity difference. As the electronegativity difference is higher, there are more possibility of transfer of electron. One atom are having very less electronegativity. One atom is having a more electronegativity. So there will be a ease for them to transfer an electron. We'll see this in detail when we will see electrovalent bonding. Now we will see formation of electrovalent compound. Electrovalent compound bonding happens through a transfer of electron. So in that there will be two kind of atom. One will be metallic atom which will lose the electron, and other one will be non-metallic atom which will gain the electron. One will lose, one will gain. So this, in between these two, a transfer of electron will take place and they will make electrovalent bond. We'll see in detail. Metallic atom will be having 1, 2 and 3 valence electrons. So to stabilize its octet, they will lose all these 3 electrons. Either they will have 1 or 2 or 3. So how much ever electron they will lose, those many positive charge they will gain. If it is losing 1 electron, for example, A is a metallic atom, it is losing 1 electron. That's why we have kept here minus sign, because it is losing 1 electron and it is gaining 1 positive charge. A is a metallic atom gaining 1 positive charge via losing 1 electron. This process is known as oxidation because it loses electron. To understand more about oxidation and reduction, please check my another video based on oxidation and reduction. Now what will happen in case of non-metallic atom? They are having 5, 6 and 7 valence electrons. To acquire a stable electronic configuration, they will gain 1, 2 or 3 electron in their valence shell and they will complete their octet. So here an example for 1 gaining electron. That B is a non-metallic atom. It will gain 1 electron. That's why we have written here plus. It will gain 1 electron and will become B minus. This is again a reduction because it is a gaining of electrons, and that's why it is a reduction process. So one will lose electron, one will gain electron, and this will become a transfer of electron in between two atoms. So combinedly, A will lose 1 electron and B will gain that electron. So in turn, A will become positive, B will become negative, and A and B will make a electrovalent compound. Now we'll take one example for formation of electrovalent compound. Here we have taken example of sodium chloride formation. When an electrovalent bond is forming, one atom will lose electron and one atom will gain electron. So here, as a metallic atom, sodium is there whose atomic number is 11. Its electronic configuration is 2, 8, 1. Whereas non-metallic atom is chlorine whose atomic number is 17 and electronic configuration is 2, 8, 7. To know and to learn more about how to write electronic configuration, please see my video based on electronic configuration. So here, when sodium and chlorine both will form electrovalent compound, sodium will lose its outermost 1 electron and it will form a stable electronic configuration. It will form a stable atom like a nearest noble gas neon. Whereas the chlorine, it has a 7 valence electron and it will gain 1 electron and form a noble gas like argon's electronic configuration. It will form a stable electronic configuration just like argon, whose atomic number is 18 and electronic configuration is 288. In turn, sodium will give one electron and chlorine will be gaining one electron. Now if we will see based on the reaction, this is sodium. When it loses one electron, which sign will come here? It will be minus. Why? Because sodium is losing one electron. When a metallic atom will lose one electron, it will form Na plus. Na will become positive. It is a cation. And which reaction is this? When any atom loses electrons, it is oxidation. Now, what about chlorine? When chlorine is gaining one electron, when it gains, we have to put here plus. After gaining one electron, chlorine will be having one negative charge. And once it is gaining the electron, this reaction is known as reduction reaction. So, as sodium and chlorine, this minus 1, this plus 1 will be cancelled, and here it will be Na plus Cl minus. In turn, they will form NaCl electrovalent bond. So now this electrovalent bond we are showing, or we are demonstrating by two different methods. One is electron dot structural diagram and other one is orbital structural diagram. When one basic difference between these two is, when we are showing a dot structural diagram, we will show only valence electrons. Only we are showing valence electrons. Whereas the orbital structure diagram, we are showing all the orbitals present in the atoms. First we will see dot structural diagram. So here it is Na. As I said earlier, we are showing only valence electrons. So Na is having one valence electron. So I have put as a dot. Its electronic configuration is 281. Whereas Cl, to differentiate between Na and Cl, I have mentioned this as a cross. So 287, so we are mentioning only this 7 electrons, we are showing only this 7 electrons. Now when this one electron is being transferred over here, then after that Na will become plus and Cl will become minus. Now if you have noticed, all I have written is cross, because once Na will transfer its electron, that electron will go to the outermost shell of the Cl and it will behave as if it's Cl's electron. It is no more sodium's electron. So this is Na plus and this is Cl minus. If you will see the electronic configuration, that after losing one electron, Na will be having 28 and Cl will be having 288. So electronic configuration will change after transferring of one electron. That means one electron is completely being removed by Na's orbital and it has been replaced into Cl's orbital. So this is all about electron dot structural diagram. Now we will see orbital structural diagram, where we are showing all the orbitals present in sodium and chlorine. According to its electronic configuration 281. So I have made 3 orbits. The innermost orbit will be having 2. The middle one will be having 8 electrons and the outermost orbit will be having 1 electron. The same for the Cl, that 2, 8 and 7. So 2 electrons, 8 electrons and 7 electrons. So this 1 electron is being transferred over here. Whenever you are drawing this kind of diagram, please make sure that you are placing electrons at equal distance. Don't draw this diagram so big or so small that examiner cannot locate the electrons. Then 1 electron is being transferred to this outermost shell and it will come here. Once it will come here, this Na will become 2, 8 and Cl will become 2, 8, 8. you have to show that here only 2 and 8. After transferring one electron, this orbital will be vacant. There are no electrons in this. So there is no need to show the last orbit of any. After the charge formation, this will become plus and this will become minus. When you are showing Na plus, please don't show the third orbit because it is vacant. So here it is 2, 8 and here it is 2, 8, 8. So they are acquiring a nearest noble gas electronic configuration like neon and argon, and in turn they are forming NaCl. So this is all about NaCl. Now we will see two other examples of electron transfer or formation of electrovalent bond. First we will see the transfer of 2 valence electron in calcium oxide, and other example is transfer of 3 valence electron in magnesium chloride. These two are two different kind of example in which we will show that how 2 electrons are being transferred and how 3 electrons are being transferred. So first, calcium oxide. In that, calcium is a metallic atom, oxygen is a non-metallic atom. Calcium's atomic number is 20, so its electronic configuration is 2882, whereas oxygen is non-metallic atom, so its electronic configuration is 2, 6 and its atomic number is 8, so electronic configuration is 2 and 6. Now, if you will see that this is a valence shell electrons, and as a metal it will lose this 2 electrons, whereas oxygen, a non-metallic atom, here it has to stabilized by gaining 2 electrons, so it will become 2, 8. This will acquire after losing 2 electrons argon's electronic configuration, the nearest noble gas, and here oxygen will become 2, 8 after gaining 2 electrons, just like a nearest noble gas, neon. To understand more about this electronic configuration, please see my video based on how to write electronic configuration and how the atoms will be stable. Now, this will gain here 2 electrons and it will become 2, 8. So whatever 2 electrons has been donated by calcium will be gained by oxygen. Now here we will see calcium will donate 2 electrons. So this will become minus because it is losing 2 electrons. Now as earlier we have discussed that how much electrons they will lose, that many charge they will gain. So calcium is losing 2 electrons, so it will gain plus 2 charge. Either you can write with 2 plus or you can write with plus 2. Here oxygen is gaining 2 electrons, so it will become plus 2 electrons, and so the oxygen will carry a minus 2 charge. In turn, calcium and oxygen, so here it will become Ca plus 2, oxygen minus. These two will be attracted by each other because one is cation, one is anion, and they will form an electrovalent bond. So in turn, the calcium oxide is an electrovalent bond. We will see this with the help of electron dot diagram. In electron dot diagram, we are showing only valence electrons. So in calcium, 2 is a valence electron, 2 are valence electrons. So this 2, both the electrons will be donated to oxygen, both the electrons. So here, after donating these 2 electrons, the calcium will become only 288 and it will form a stable electronic configuration just like argon. Here, after getting these 2 electrons donated by calcium, this will become 8 and it will get an electronic configuration just like neon. So this will become plus 2, whereas here it will become minus 2. 2 electron has been donated, so plus 2 charge has developed. 2 electron has been gained, so minus 2 charge has been developed. So the new electronic configuration attained by calcium plus 2, the cation is 288 and oxygen minus 2 is 2, 8. This 2 will combine with electrostatic force of attraction and they will become calcium oxide. Because of the cation and anion, they both are oppositely charged atoms. They will attracted by each other and they will combine and form electrovalent bond. This is by transfer of 2 valence electrons. Now we will see the other example of a transfer of 3 valence electrons. Here we have taken an example of magnesium chloride. Magnesium's atomic number is 12, its electronic configuration is 282. The chlorine's atomic number is 17 and its electronic configuration is 287. Now here magnesium as a metallic atom, it will donate 2 electrons and form a stable configuration just like a neon. Chlorine is a non-metallic atom and it has 7 valence electrons, so it needs to gain 1 electron and to become stable like argon. Here we have to understand that magnesium is donating 2 electrons, but at the other side chlorine requires only 1 electron. So to stabilize this 2 electron or to absorb this 2 electron, we need other 2 chlorine atom. So magnesium is donating 2 electrons whereas chlorine requires only 1 electron. So we need to absorb 2 electrons. That's why we will take 2 chlorine atom here. This concept you will learn more in combining capacity of atoms. So here we need to take 2 chlorine atom. An electrovalent bond will formed in between 1 magnesium atom and 2 chlorine atom. So here 1 magnesium atom is donating 2 electrons. So it is losing 2 electrons and will form Mg plus 2 ion, cation. Now here this 2 electrons is being absorbed by 2 different chlorine atoms. So that's why we have written 2 in front of the chlorine. Here it will gain 2 electrons. 2 chlorine atom will gain 2 electrons. That's why it will become 2 Cl minus. 2 chloride ion will be generated. 2 different chlorine atom will gain 2 electrons and it will become 2 different chloride ion. This is cation, this is anion. So here it will Mg plus 2 Cl, it will become Mg plus 2 Cl minus 2 Cl minus. Why? Because 2 different chlorine atom is there. So Mg plus 2 Cl minus, it will become MgCl2. So the same thing we will represent on the dot diagram, that Mg 2 electrons. In dot diagram we are only representing valence electrons. So this 2 electron will be absorbed by 2 different chlorine atoms. So 1 electron will be taken up, will be absorbed by 1 chlorine, and other electron will be absorbed by other chlorine atom. So here the charge formation will be plus 2, here it will become 2 Cl minus. So here the electronic configuration will be 2, 8 and here the electronic configuration will be 2, 8, 8. So in turn the MgCl2 magnesium chloride will formed. Now we will see for orbital structural diagram. So where you are placing the Cl, please make sure that you have to place Cl on either side of Mg. So one Cl will be at the other side and other Cl will be at the another side. So it will be easy to show that how magnesium is donating these 2 electrons to 2 different Cl. So this Cl will comes here and it is donating its outermost shell's electron, and here the another electron will be donated to other Cl. So here after donating this, Mg will become Mg plus 2. So here this will not be there. So 288 it will gain, and here it will become 288 and here it will become 288. So in turn the MgCl2 will be formed. So these are 2 different examples where two different electrovalent bond has been formed. One is calcium oxide and other one is magnesium chloride. Now we will see a covalent bonding. First of all, what is covalent bonding? So, bond formed due to a mutual sharing of electrons. Earlier we have seen electrovalent bonding where the transfer of electron will be taken place. One atom, a metallic atom, will give electron to non-metallic atom. Metallic atom will lose electron, non-metallic atom will gain electron. Here there won't be a transfer of electron. Here it will be a sharing, and it will be a mutual sharing. When it will be a mutual sharing, then electrons will remain in between two atoms. So this kind of mutual sharing is known as covalent bonding. Basically there are two types of covalent compounds. One is polar covalent compound and other one is non-polar covalent compound. But we will see this in detail once we will have a basic idea about covalent compound. So these are some of the examples. We will see one by one, and we will see and try to have an idea about how the electrons are being shared in between two same kind of atom. We have taken here all the non-metallic atoms and they are forming a bond with the same atom. Means hydrogen will share electron with another hydrogen, oxygen will share electron with another oxygen, and nitrogen will share electrons with another nitrogen. So first, covalent bonding, bond formed due to the mutually shared electrons. Right? So first example, sharing of one pair of electron. First we will see that only one pair of electron, how it is being shared. So hydrogen, its atomic number is 1 and its electronic configuration is also 1. To complete its duplet, remember that hydrogen is following a duplet. Hydrogen will try to gain a stable electronic configuration just like a nearest noble gas, helium. So hydrogen needs to gain one electron to complete its duplet to get a stable electronic configuration. So it needs one more electron in its outermost shell. So here there is no transfer of electron. One hydrogen will share one electron with another hydrogen. Only for the understanding purpose, I have marked this electron with cross. So it shows that this electron is from this hydrogen and this dot electron is from this hydrogen. When they are sharing, so this we are writing as if we are sharing it, two electrons in between two hydrogen atoms through Venn diagram. You all know what is Venn diagram. So these two electrons will remain in between these two hydrogen atom. Nor towards, it won't be towards any one. It will be in between. This pair of electron, they are two. So we are terming as a pair of electrons. So this is pair of electron that will be in between two hydrogen atom. While they are sharing one pair of electron, it is making only one bond in between hydrogen, and ultimately it will be our H2 molecule. Again, two hydrogen atoms are sharing one pair of electrons. They are forming one covalent bond and it will become a H2 molecule. So it is by sharing of one pair of electron. Another example we'll take where the sharing of two pair of electrons are taking place. Here we have taken oxygen, its atomic number is 8 and its electronic configuration is 2 and 6. So here the outermost valence shell is having 6 electrons. To complete its octet, it requires how many electrons? 2 electrons. So it requires 2 electrons. So this is one oxygen atom, this is another oxygen atom. This two oxygen atom will share this 2 electrons among each other. So here I have denoted that this oxygen atom's 2 dot, this 2 electrons, this oxygen atom, there are 2 cross from this oxygen atom. So they are in between, they are sharing 4 electrons and 2 pair of electrons. Remember that when they are sharing 2 electrons, it is 1 pair of electron. When they are sharing 4 electrons, it is 2 pair of electron. And since they are sharing 2 pair of electron, they are making here 2 bonds in between. So oxygen double bond, and they are forming oxygen molecule here. Again, oxygen requires how many electrons? 2 electrons to complete its octet. So it is going to share 2 electrons. So this 2 oxygen atoms will share 2 electrons. This oxygen will give 2 electrons. This oxygen also will give 2 electrons. So this 2 cross electrons is from this oxygen, but when it is in the form of the sharing, it behaves as if it is there in its octet also, and this 2 dot electrons where it is being shared, it is behaving as if it's this oxygen atom's electron also. So while sharing, they are following its octet rule. See, if you can count 1, 2, 3, 4, 5, 6, 7, 8. So this octet has been completed for this oxygen atom. And if you will see this, then 1, 2, 3, 4, 5, 6, 7, 8. So this octet is also been completed for this oxygen atom. So by sharing of 4 pair of electrons, both the oxygen will complete its octet rule, and they are gaining a stable electronic configuration just like its nearest noble gas, neon. Now third example we will take. In this, sharing of 3 pairs of electrons are taking place. So here we have taken example of nitrogen. Its atomic number is 7. So electronic configuration is 2, 5. So to complete its octet, it requires how many electrons in its valence shell? Correct, 3. So it requires 3 more electrons in its valence shell. So one nitrogen atom will share 3 electrons to another nitrogen atom, and this nitrogen will share 3 electrons to this nitrogen atom. So while they are sharing 6 electrons, in turn they are sharing 3 pairs of electrons. So when this nitrogen is taking this 3 electrons, its octet has been completed. If you will see this 1, 2, 3, 4, 5, 6, 7, 8. So this 8 electrons is also belongs to this nitrogen, and from here this side, this 8 electrons is also behaving as if it is there in this nitrogen. So for both the nitrogen, the octet rule has been completed. So by sharing a 6 electron and 3 pairs of electron, nitrogen atom will form 3 bonds in between them, and they are forming N2 molecule, nitrogen molecule. So once again, covalent bonding, it's a mutual sharing of electron. When it is sharing 1 pair of electron, it is making 1 bond. When they are sharing 2 pair of electron, they are making 2 bonds. When they are sharing 3 pairs of electron, they are making 3 bonds. Just for the remembering purpose, just remember that when there are 2 electrons, they are forming 1 bond. 4 electrons they are sharing, that means 2 bond, and 6 electrons, that means 3 bond. In covalent bonding, we have seen single bond, double bond and triple bond with the help of example of H2 molecule, oxygen molecule and nitrogen molecule. We have also seen that where a single bond covalent bond formation will happen, 1 pair of electrons will be shared. When double bond covalent bond will happen, 2 pairs of shared electron will be there, and with the triple bond 3 pairs of shared electron will be there. Now all these examples what we have seen, it's with hydrogen, oxygen with oxygen, and it is nitrogen with nitrogen covalent bond. That means two same atoms are forming a covalent bond together. Now we will see one more example where two different atoms are forming covalent bond between them. So here we have taken carbon tetrachloride's example, that is CCl4. So in that, one carbon will form a 4 different covalent bonds with 4 different chlorine atoms. So first of all, carbon atomic number 6, its electronic configuration 2, 4. So it's required a 4 electrons in its valence shell to complete its outermost valence shell, and it will follow a nearest noble gas neon's electronic configuration to become stable. Now chlorine, as we have seen earlier, its electronic configuration is 2, 8, 7, and it requires 1 electron to complete its outermost shell and to follow octet rule, and it will acquire a nearest noble gas argon's electronic configuration. So here if you will see, carbon requires 4 electron, whereas chlorine require only 1 electron. So sharing of 4 electrons and 1 electron will happen something like this. So in between a 4 chlorine atom, 1 carbon atom will be there, where I have shown only a valence shell electron. If you will see, chlorine 7 valence electron, chlorine 7 valence electron, and same for this 2 chlorine also. Whereas in carbon there are 4 valence electron. So I have shown 4 valence electron. Now carbon requires 4 more electrons, whereas chlorine require, all the chlorine require 1 electron to complete its octet. All the chlorine will require 1 electron. So this center carbon atom will share 1 electron to all the 4 chlorine atom, whereas chlorine will give only 1 electron to carbon. This chlorine will give only 1. That means it share only 1. This chlorine will share 1. This chlorine will share 1. And same for this chlorine also. So 4 chlorine will share 4 electrons, whereas this carbon will share 1 electron to 4 different chlorine atom. So if we will see here, this green is carbon's electron. There is no difference between these electrons. Just for the understanding, I have made this color coding, that carbons, this electron, this electron, this electron and this electrons, once the bond will form, this electron will behave as if it's in this chlorine's octet. This electron will behave as if it is in this chlorine octet. At the same time, this electron will behave as if it is in this carbon's octet. So in turn, all this 1, 2, 3, 4 and 5 atoms will share this many electrons. They are sharing 4 and 5 electrons, and they are completing 4 covalent bonds. So each carbon will be having a covalent bond with 4 different chlorine atom, and the molecule formed is carbon tetrachloride. We have seen some of the example for covalent bonds. Now this is for you to practice. First, bond formation Cl2, that chlorine molecule covalent bond, how one chlorine atom will form a covalent bond with another chlorine atom, and it will form chlorine molecule. Another bond formation for CH4, methane. One carbon atom will form a 4 different covalent bond with 4 different hydrogen atom. For this, you can just refer oxygen bonding, O2 molecule. For this, you can just refer carbon tetrachloride covalent bonding, bond formation. Try yourself and see.